Hello everyone, good day to you. My name is Ardaffa Kemal Rasha, and today I'm going to explain about the future of fuel cells, especially in the fuel cell vehicle region. Let's get going. First of all, what is a fuel cell? A fuel cell is a galvanic cell that converts the chemical reaction energy of a continuously supplied fuel and an oxidizing agent into electrical energy. A fuel cell is not an energy storage device, but a converter. The energy is supplied in a chemically bound form with the fuel. The energy efficiency of a fuel cell is generally between 40% and 60%. If waste heat is captured in a cogeneration scheme, efficiencies of up to 85% can be achieved. Although fuel cells are often referred as hydrogen energy fuel cell, many other fuels can be used in addition to the hydrogen, such as methanol, butane, or natural gas. Next, these are the classifications of a fuel cell. The first one is PAFC or phosphoric acid fuel cell. It has a capacity of 50 kilowatts to 11 megawatts. Second is MCFC or molten carbonate fuel cell. It has a capacity of 30 kilowatts to 1 megawatt. The third one is SOFC or solid oxide fuel cell. It has a capacity of 1 to 25 kilowatts. And last but not least is SPEFC or solid polymer electrolyte fuel cell. Due to its high electric efficiency and its current temperature-specific incompatibility for mobility, the most promising fuel cell for power system is the SOFC. The advantages of SOFC in the field of power generation is its high temperature waste heat production, which could be integrated in current cogeneration system. Thus, it's significantly raising the efficiency of the system. Okay, this is how fuel cell works. Inside a fuel cell, hydrogen together with oxygen or air is converted to steam. For these two electrodes, the anode and cathode are set into an electrolyte. During the process, an electrochemical reaction takes place. Compared to thermal engines, fuel cells have the advantage of a direct conversion of chemical energy into electrical energy. Thermal engines have to convert the chemical energy into thermal and mechanical energy by the combustion of fuel. Mechanical energy is then used to operate a generator, while the thermal energy remains unused in many applications. Consequently, the theoretical efficiency of a fuel cell is much better compared to thermal engines, as the theoretical achievable useful work is much better, and it's limitedly solely to free the enthalpy of chemical reactions and can therefore be higher than the coupling of thermal engine. These are some of the advantages and disadvantages of fuel cell. The first advantage is fuel cells are direct conversion of chemical energy into electrical energy. Uh, then the theoretical efficiency of a fuel cell is much better compared to thermal engines, and storage density of the fuel of the chemical fuel is very good. And these are the disadvantages. The first one is hydrogen is difficult to store and is currently expensive when produced from renewables. Also, investment costs for fuel cells are relatively high compared to batteries and thermal engines. These advantages is why fuel cell is not quite popular in our country of Indonesia, and hopefully, maybe in the near future, it gets better. Okay, these are the two main areas of fuel cell technology. The first one is fuel cell vehicles, which I'm gonna go in depth uh, next. And the second one is power technologies, such as combined cycle power plant, cogeneration, and residential generation. Okay, these are some of the Fuel cell vehicles. The first one is a car. That is a Honda Clarity produced by Honda. Next is a motorcycle produced by Yamaha. And above there's an airplane made by Boeing. There's also a submarine here that uses fuel cell. Uh, this bus produced by Mercedes-Benz also uses fuel cell. The forklift produced by Toyota also uses fuel cell. This train also uses fuel cell as power. And lastly, this boat also uses fuel cell as a source of power. As you can see, fuel cell vehicles are not only about cars, but many other vehicles use fuel cell. Okay, this is a fuel cell car. Uh, as you can see here on the right, that is this schematic of a fuel cell car. Uh, it uses hydrogen combined with oxygen, which is used to generate the electricity. It is classified as zero emission vehicle that only produces water and heat, and it can be fueled in less than 4 minutes, and it ranges up to 480 kilometers. These are the history of fuel cell cars. This picture right here is the Honda FCX V4. This is the first fuel cell car to be approved in American roads. It is produced in 2002. It costs around $11,500. It's ranging around 260 to 310 kilometers, and it is produced until 2007. And down below, you can see the list of fuel cell cars produced from 2002 to 2018. The Ford Focus, Nissan X-Trail, Mercedes-Benz, Chevrolet Equinox, and Hyundai Tucson. These five cars is no longer produced right now. Okay. And this is three cars still in production right now. The first one is the Toyota Mirai. This is the 2021 version. The Honda Clarity. This is also the 2021 version. And the Hyundai Nexo. Yes, these are the specifications of which fuel cell cars still produced. The Toyota Mirai have a range of 502 kilometers. It has a power of 182 horsepower with a torque of 300 Newton meters. It costs around $58,500. The Honda Clarity have less range in 480 kilometers. It also have less power in 138 horsepower and 299 Newton meters of torque. And it costs similarly to the Toyota Mirai around the 58,500 region. And last is the Hyundai Nexo. It ranges 600 kilometers and its power is 160 horsepower with a torque of 394 Newton meters. The Hyundai Nexo is cheaper than the other two options. I think that is all from me. Thank you very much for listening to my presentation. I hope for the future, fuel cell technology, especially fuel cell cars, can be used more in our country. And I will be looking forward towards it. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.